Hello everyone, welcome to the very special episode of the Undermind podcast, in which I interview a beginner to the AI world, along with my two other more technical and professional guests who will guide this young man's journey into AI development. With that, I would like to ask everyone for a more detailed introduction this time. And first it's, the guest of honor. His name is Ravi or feardragon. I think that's the caster's name. And with that, please introduce yourself.
Hello, as just described, my name is Ravi or feardragon. I am both a StarCraft 2 commentator as well as a software developer of about 5 or 6 years now.
What languages do you work in?
So I've worked in a variety of languages. I've gone from C++ to Python to Golang to Java to JavaScript frameworks and stuff. So it's been pretty across the board, but I mostly specialize in web applications.
And what made you interested in StarCraft bot development?
So I think for me, the AI development has been really interesting. And of course, I'm more on the StarCraft 2 side, but I've been seeing and watching a lot of like the Brood War AI development happen over the course of the years. I remember when UC Berkeley had a AI class, which I thought was really cool. So there's been like, I think, little spatterings of the StarCraft 2 and StarCraft Brood War AI like in my life. And I think it's just a really cool time to start getting into it and learning a lot more about how that AI development works for StarCraft Brood War and StarCraft 2 with the whole DeepMind stuff coming up.
Yeah, and actually fun information that the Berkeley Overmind bot had another fork, I think, called the Undermind. I was just become aware after naming my podcast the Undermind. This has no relation to this whatsoever, but it's a fun fact. Okay, following the detailed introduction, my next guest is Hannes Bradberg. AI developers know him. Imagine this with the doctors hate him kind of message. AI developers know him. So Hannes, would you mind giving a detailed introduction to the audience?
Sure. My name is Hannes Bradberg, or Newbeard, as some of you might know me. I am a data extraction engineer by day. I do mobile forensics and stuff like that, and I just started watching and also a student, and I watched the Twitch stream. I kind of found it interesting. I ended up making my bot about 2 years ago, and after, as a direct cause of that, I created a FAP library for approximating and simulating battles and the battle outcomes for StarCraft AI. And now I guess I'm kind of ended up as a maintainer of the Brood War API that the bots use.
Brood War API is a topic of discussion in itself, I think. But before we do that, let's introduce our next guest, who is Jaegers.
Hi, so my name is Jasper, or Jaegers, and I'm a computer science student. I got introduced to StarCraft AI 2 years ago now because of a course at my uni. We had to write a bot from scratch in like 2 months in a custom language that we had to learn from the university called Goal.
Goal as in the goal of something, or with a U, like the goal people?
Goal like the language, Goal.
Oh, okay.
I don't have a real bot on the ladder at the moment. I'm working on something in private, and
JPW API.
Oh, right. And I'm I created or maintain a Java API for Brood War called JVAPI, and based on something that Newbeard made himself.
And I'm considering switching to that. BW API, as I said, is a big topic of discussion, and you will find that it's not easy to pick which library to work with. With that, I'd like to ask Ravi to ask his first question.
Yeah, so I think My first question is going to be kind of an obvious one, but let's say I want to get into AI development for StarCraft. Where do I even begin? What are the best resources you guys know of? Besides this, obviously, this podcast.
I think for beginning, this podcast is not a great resource. It's kind of an inside job. But a great point to begin is the SSCI tournament website. There you find a tutorial which is horribly outdated but still usable thing. And second to that is the Discord channel of the SSCI AIT. Basically all bot developers hang out there. Now, the first thing you need is decide which language would you like to develop your bot in. The main choices are C++ and Java. Both are equally valid. Shut up, Hannes. And I think it's just a matter of choice.
Yeah, okay. That makes a lot of sense.
Yeah, I was just gonna say I wouldn't rank the SSCIT website first for like tutorials on how to do things, but you can use it as a bot list to find people's GitHub repos and read their code, which I think is probably the number one source, in my opinion, on how to do things. And second hand, probably the SSCIT Discord.
Is there a language that's most commonly used? Because I know you said there were multiple options.
Well, yeah, to be honest, I think C++ is more common, probably has around twice as many bots, but many of, like, I think a lot more of the C++ bots are closed source, but there are probably still more open source C++ bots than there are Java bots. And also, the main bot frameworks are also written in C++.
But basically, most or a lot of bots are forks from UAlberta bot or Steamhammer, and those are written in C++. So that's a common starting point.
Yeah, that makes a lot of sense. Are there ever performance concerns when you're developing like the AIs? So there's some incentive to use C++ over Java for that reason?
Yes.
Yeah, it pretty much there is a difference, but it isn't as much of a language difference as it is an interface difference, because there are both client and DLL bots, and DLL bots get loaded directly into the game and therefore run much faster, while a client has to communicate through shared memory. And the Java bots only support the shared memory approach, while if you write a C++ bot, you can actually make it a DLL.
Oh, okay. Yeah, that is a pretty big difference then. Okay.
It does not mean that Java is so slow that you can't work on it. There are many Java or JVM-based bots. For example, the latest SSCIT winner, Purple Wave, is written in Scala. So I think that's why I said that just go for it in the language you're most comfortable with. The advantage is C++, as Hannes said, is that there are many libraries that are currently only available in C++. That hopefully might change, but there are some common sets of problems which every bot author will encounter sooner or later. Most obvious is the analyzing of the terrain, because the BW API does not give you any good metrics for that. And there are some common libraries to do that.
I see. Yeah, that makes a lot of sense. So when you're developing your AI, so you're just beginning, and I'm sure you're looking at some of the source code of other developers' projects on GitHub, is there any particular like high-level structure that most AIs will maintain for like their kind of running loop?
Yes. I think, Hannes, would you mind saying a few words, or should I?
Yeah, sure. A very common pattern I see is a lot of singletons for specific purposes. Like you almost always see a unit commander singleton, and you see another strategy singleton variable and another building queue singleton variable, and or some kind of global just to keep track of state, just to compartmentalize your code. And that's generally a pattern that every single bot follows, which kind of makes it a little bit easier for you to analyze, because you can very easily compare your parts of your bot to other people's parts and see what they have done differently. But for other software reasons, those are really bad for technical reasons, but it makes it really easy to look at the code at least.
Yeah, you often have like a building manager, a macro manager, a military manager, production manager, research manager, things like that.
So are these all just running on different threads then, so that they can all operate independently of each other? How does that work interface-wise?
BW API is not thread safe at all. If you want to do multi-threaded computations, you need to synchronize your BW API access yourself. And the SSC AIT, where most people play, only has one core per AI, so you can't really gain any performance by doing that. So usually they're just called sequentially.
I think Ravi's question was mainly how do you interact with the game itself? Like, what are the entry points, the methods you can extend, overwrite, etc. Am I right about that?
Yeah, actually, you hit the nail on the head. That's what I was actually trying to get at.
Yeah, so the way it works, I'm working in the Java interface, so the C++ might be different, but as I understood, it's mostly the same in this regard. You have some interface methods which you override and or extend, or whatever it's called, your language, and these when you can interact with the game state in a specific phase. For example, you have the onStart method, which only runs on the start of the game exactly once. Here you can initialize your bookkeeping or accounting type objects, everything that you will need, but only once. The main backbone of the game is the onFrame method. StarCraft works in a way that there are frames, which is basically the game loop itself. Normally, an amount of frames is, I think, 30 per second on fastest game speed, but I might be wrong about this, or 32. So it's quite fast and quite a lot per minute. An interesting thing is SSEIT is running, I think, 25% faster than this. So if you watched any bot streams or just go to the SSEIT website, you will find that the bots play unusually fast, so that's why. Actually, you can alter the game speed yourself. And the onFrame method, which has control over these frames, okay, I phrased that weirdly, but which you can execute every frame, is your main point of interaction. Other than that, there are various unit transition or event-based like trigger methods. For example, on unit show, on unit discover, on unit hide. So if you see a unit for the first time, the on unit discover gets fired, or if you lose sight of a unit, on unit hide. There are a few of these, and there is even an on nuke detect one, and you can write your custom logic to interact with the game during these. Now, it has its quirks, and you need to learn them, and there are a lot of things that do not make sense. For example, if you build an extractor type building on a geyser, then it is not on unit create. Actually, the geyser object itself morphs to another extractor, and it gets triggered. Oh no, I said that wrong. The on unit renegade gets triggered after that. So there is an extractor which is created, then it gets renegade, which means it changes players, and it will be yours. The on renegade is the same method that gets fired when a Dark Archon converts the unit. Now, I'm sure I said some things wrong, but that's the gist of it.
Yeah, that makes a lot of sense.
Yeah, and so that's the interface where your bot gets data. There's also the interface where you send data back to the game. So in general, there's a global variable called Brood War, which you can access. You can get a list of all the players, every single unit that you can currently see, or any kind of map data or whatever you want. And you can get unit object from the game, and you can tell the unit like unit.move, and you can give it a position to go to or whatever you want to do. So you have a global Brood War object which has all the bookkeeping, and you also get pointers to units from the events. Like if you say this unit just completed, you also get the unit so that you don't have to look it up.
So when you're handling, for example, these, like, let's say you have an on nuke event at the same time that there's a, I don't know, some other event pops up, right, on the same frame. Is there some way that you know, like, the order of operations that are going to be executed? And also, I guess, like, well, I'll save the other part for this for after.
Basically,
Okay.
it's all before the unframe call. So all the events are called before unframe on the frame that it happens. So there's always an on-frame event every frame, and all the other events are called before unframe.
So I think it's an implementation detail, but at the moment, unit-related events are first done in the order of the unit IDs, and they have a specific order for the events for the same unit, and then global events are done for the game.
Basically, the game is frame locked, so everything happens per frame. So the order doesn't matter because it happens on the same frame.
I see. Okay, and like my follow-up question was actually going to be, if your computations begin taking longer than a frame, is there any way to catch yourself, or to, when you're doing your development, to realize like, oh, I'm taking longer than a frame, so I'm actually missing opportunities to take action, or I'm trying to do too many computations per frame?
The game actually locks up entirely until you finish your function, and yeah,
It waits
exactly.
for you.
The tournament, whoever runs a tournament can set frame limits and basically time your bot, and if it's taking too long, it can kick you out. But in general, BWAPI has no such restrictions. It's just, if you want to set those kind of rules, you can time your bot, but at the moment, we just wait for the bot to finish.
Yeah, exactly. It's the other way around. So it's not like a multi-threaded thing. It waits for you to execute, and that's why tournaments have time limits for a frame. I think it's 35 milliseconds in general. And I think there were a few bots in the latest tournament that get disqualified because of this, because there are a set number of frames over a set time limit which you can do.
I see. That's actually really interesting, because that almost makes it feel, even though it's like a real-time strategy game, that almost makes it a little bit more of a turn-based game in some ways.
You're completely right. Yeah.
Yeah, it's a turn-based game for bots.
Actually, I wrote an article about this called Human Games Are Not Bot Games, and draw the exact same conclusion that bots are playing a turn-based game.
Yeah, that is really fascinating to me. So, okay. One of the other questions I had was just like kind of on a similar note is, what are typical restrictions for AIs? Are there, especially in tournaments, are there typically any APM restrictions? Are there any, like, I know you've already talked about like single threaded, so doesn't really support multi-threading. It's got like that, I think you said 30 millisecond, 35 milliseconds time span you can make your moves typically before being disqualified. Are there any other notable restrictions that people should keep in mind when developing their AIs?
Like standard things that are illegal for humans, like stacking ground units on purpose, stuff like that.
Yeah, you're basically not allowed to exploit bugs, but anything that a human can conceivably do, or sometimes even that a human can't do, you can do. Okay, that sounded like a very bad rap song, but the point is, for example, you can plague on interceptors, you can mineral walk in most cases, but as you good counterexample, you can't slide buildings or stack units or that kind of stuff. But you can do, for example, a human can target something under a floating building. A bot can easily do that, and that's allowed. There is an ongoing debate how similar bot versus bot games should be to human versus human games, and it's kind of a gray area always. This is a good example what a bot can easily do.
Yeah, there are a lot of restrictions of how we want it to be, but at the moment, the only rules being enforced are the rules being enforced by for humans. Like, we're forcing the bots to follow the same rules, but we're not forcing them to play like humans at the moment.
And there's no explicit APM limits to answer your APM question.
No, not at all.
Okay. That's actually
nor
really
a
interesting.
reaction time or anything.
So they'll get into the 50k sometimes. It depends on the bot.
Yeah, that's the first part of that answer is really interesting to me, because I know that there are, for example, there was the recent or somewhat recent discovery of the stacking bug that humans could actually pull off, so that Protoss players, for example, could mass recall like a large chunk of their army. And I guess I'm not 100% sure if that's been disqualified from human tournaments yet, but I know that you were just saying that, like, stacking, for example, stacking all your units together would be something that would be grounds for disqualification. So I guess is there like a concrete place for the enforced rules that's listed somewhere?
As far as I know, the SSCAIT website has a rule list which includes all of the points we brought up.
Gotcha. Oh, I was gonna almost topic transition by asking. I know that there are a lot of quirks of Brood War. I played Brood War when it like came out, or when StarCraft 1 came out, and I've been playing it kind of on and off for years. And I tried to play competitive as a human for a little bit on like IC Cup and stuff, and I got to like D+. But even then, I still don't feel like I know all the little quirks and intricacies of Brood War. There are so many small little details in how you control units and everything. Do you guys have any recommendations for ways to quickly learn these? And I'm sure that there are even more of these little quirks when you start working with bots that have these uncapped APM limits.
You're right about that.
To answer your question, there are no quick way to learn this. You must learn it through blood, sweat, and tears. But a good starting point is to collaborate with others and read every related resource. Like Jay Scott's blog is a great example. My blog is an example, and there is the very helpful SSCIT community when they are not spamming memes. So like 10% of the time. But that's a starting point. Actually, we are speaking and planning to compile some resource for beginner AI developers, because it's a quirky field. For example, we didn't even mention that Brood War bots use the 1.16 version of StarCraft. So that's just one thing. We very much hope for a StarCraft remastered support, but that's in the future as of yet.
I see. Yeah, that makes a lot of sense. I think one other question that I did have was, so like, let's say I've started using other GitHub repos, I've gotten my start base, I have my main structure, and I'm using like the on-frame methods and all this stuff. I've written my bot, cool. I want to test run it, but I'm still very early on in development. I don't want to, I guess, necessarily try to go up against other people's like very strong and well-developed bots. What are the ways that you kind of get started as I've got something brand new that I want to try out? Where's the testing grounds? How do you try out your bot and then learn from the mistakes and trying to adjust?
So the main way I usually do it is that BW API actually makes it kind of easy. You can edit a config file and you can just make it automatically play a game at like unlimited FPS. It will play out the entire game in like 3 seconds, and you can see if anything goes wrong. You can of course play it back slower if you want to see what's happening, and you can just automate playing games very easily. You can also set up Docker containers using BW Docker, I think that's the name, or SC Docker. Yeah, that's it. And you can basically make Docker images to automatically play games too.
A simpler way, and when you are beginning from scratch, is just use a tool called Chaos Launcher, which has integrated bot support. And the way it's used is you just run your bot and start a game, and you can see in real time what your bot does. This is very helpful when you are in the beginning stages. Later, when you get to the stage when the actual matches matter, I would use something more automated. But things like building placement or scouting or something like that, when you are not curious only about the result but the process itself, it is helpful to understand and just see your bot in action.
Okay, cool. That makes a lot of sense, and that sounds like really good advice. I think those are most of the things that like were off the top of my head that I was really interested in. Do you have any like general gotchas or advice that we haven't really talked about so far?
To be honest, latency is gonna be a real mess. You're gonna see strange things happen just because it's a multiplayer game and it has to deal with people having way different internet connections. You're gonna issue an order, you're gonna see the order change, and then it's gonna flip back and it's gonna be all quirky, and you're gonna ask yourself, wow, why is it doing this? And the answer is most often latency. And the latency compensation inside of the current BW API is very messy, but we hope to have the 4.3 update ready as soon as possible to maybe make that a non-issue, or at least that's what we're hoping. Generally, you're gonna see many weird things happen in Brood War because it's a very old and hacky game. And the best advice we can like give is to ask, like, I'm seeing this thing happen, this is what I'm doing, and someone in the Discord is probably gonna know what's happening.
Well, I think we are going way ahead with this. And the basic thing you need to do or need to discover is just how the API works, because it's not intuitive in most of the cases. And when Hannes said it's hacky, he didn't mean that the API is hacky, but the Brood War, the game itself, is a hack-together mess. And we are not dissing it. This has been admitted by the developers themselves. You mentioned you played Brood War some. Did you notice how awfully stupid the dragoons are when going up a cliff?
Yes, as a Protoss player that played Protoss versus Terran primarily, this was every day of my life.
So the reason for that is not because it uses some quirky algorithm, but when a goon steps, the unit actually changes size. So it's a differently sized unit, and that just screws the pathfinding. So that is why the back and forth keep happening. Other units don't necessarily have this problem.
I see. So knowing some of these quirks, are there things that you can do, like you can have your own internal calculations for pathing, or is that not really something that's feasible?
It is.
I was going to say that, for example, Locutus, a Protoss bot, has extremely good Dragoon micro, where you almost never see a Dragoon misstep or something like that. It's really amazing to watch. So it's definitely possible.
And it's open source.
Yeah, that was actually going to be my follow-up question on, are there a lot of libraries for, because I know you guys are saying a lot of things are developed in the singleton fashion. So are there a lot of libraries for example, pathfinding for Dragoons that are a bunch of tools or resources that allow you to much more effectively calculate the path that they should take, or things like that? Or I want to split up my Marines or something. I want to do some sort of action. Like, are there useful libraries out there that help you, I guess, write or not duplicate code that's already been written?
For micro, not as much, but quite some for like decision making with combat simulators and stuff like that. But there's not, to my knowledge, that many micro libraries.
Yeah, the things that were mentioned earlier, like macro management, was things like, well, more like placement of building, terrain analysis, combat simulation. There's even a library for making up build orders, but there's not that much for micromanagement. That has mostly been something that everyone does their own kind of way.
And pathfinding is a very big issue, and while Brood War itself has a built-in pathfinding, it lacks some capabilities, as you might have discovered when trying to move dragoons up a ramp. So people are tackling this, but in general, in like a theoretic fashion, pathfinding in 2D grids or 2D fields is something that is researched a lot. And we talked about this multiple times in this show. The go-to algorithm seems to be the jump point search, which is a very, very good and fast algorithm. It's a vast improvement over the previously dominant A-star algorithm. I don't know if this says anything to you, but if not, just Google it. It's not even that hard to understand, even if you're not a computer scientist or something. So since this is AI research, a lot of stuff, theoretical research, can be applied here. So that's helpful. Implementing it, well, that's another question.
Yeah, as far as I know, McRae, for example, just copy-pasted a A-star search from GitHub and just uses it, and it just works great inside of Brood War. It's like there's no problem doing that if you want. Or, sorry, a jump point search, I meant.
Yeah, that's really cool. I also wanted to ask, like, so when you have a human playing Brood War or something, you can oftentimes think like these multi-step plans. So a human is not necessarily evaluating the game from just the current game state. They're looking at something and they're saying, here are the next 5 or 6 moves I'm going to do. Whereas I know with a lot of, for example, like chess AIs and stuff these days, you can pre-compute the entire like or so many scenarios already in advance, and you can look at each individual board state and not worry about past actions that were planned or anything like that. So I guess the roundabout way of what I'm trying to say is, or like the less roundabout way of what I'm trying to say is there a good way to manage your game loops such that if you have things that you say like, I need to move my marine to this location and then to this location, how do you track like future actions or you want to execute on future frames? Are there any kind of structures you guys find useful for those kind of multi-step actions? Let me know if that didn't make any sense.
It did, and I think Hannes and Jägers is just thinking very hard at the moment. But actually, you hit the nail on the head, because this is what AI is about, like planning long term. And well, to fill out the time while they'll gather their thoughts, your chess analogy is not really applicable here, because in chess you see the board all the time. In StarCraft, you get the combinatoric explosion much faster, because there are a lot more units which can do a lot more things, so it's computationally infeasible to just calculate every game state and deduce from that the best path. But even if you could do that, the problem is you have incomplete information. You don't see everything at once. You don't know what your enemy is doing. For example, you don't know your enemy's resource at any point during the game. So that's why you need to really play the game and not just go along a predefined path.
Yeah, that's pretty much what he said. This is the kind of issues that we're trying to quote-unquote solve, and which AI research is about. Like you could, of course, just have some standard library queue and just read the actions you want to do and how your game plan. But yeah, this is what AI is all about and what's so hard.
And of course, if you figure out something, the bot versus bot meta will evolve for you to not be able to do that.
Gotcha. So for getting started, are there anything along those lines that like people have found are effective ways to go about that kind of like long-term planning or management?
I think what most players do, most developers I think, is try to replicate basic human strategy. And where 4-pool is the most popular, please don't do any more 4-pool bots.
Yes.
And I'm saying it because I have a 4-pool bot right now on the ladder, and that's a good starting point, because at this stage of AI, the games are quite similar to human versus human games, in that aspect that they are following well-established strategies and unit compositions. That being said, there are some strategies or micro which are only feasible for bots. With AlphaStar, you saw that in StarCraft 2, no human can replicate that pixel perfect jumpy protosting micro that it did, and
yeah,
I don't know what's the unit called.
Oh sorry. Yeah. No worries. The stalker, the stalker blinking, I think.
Yeah, I don't really play StarCraft 2. But in Brood War, I think Locutus's Goon Micro is a close example for that. But imagine you have infinite micro and what you can do with it. Or yet another good example, Vulture Micro. It is a good thing, and humans can micro vultures, but usually one at a time and not doing much during that. Bots can easily micro 10 vultures, no problem. So there is no attention economy to speak of in bot games. I guess that's the conclusion here.
Right. You can basically, as long as you write decently effective code, you can reevaluate everything on every frame. But if we're talking like high-level decision-making, we've seen, I don't know if this was your question, but if you're talking, did you mean like what kind of unit you should make, or what your goal is based on in-game information? Was that your question?
Yeah, absolutely. So like an example would be, you maybe have like a build order or something, but suddenly there are cannons in your base, or actually no, that's not a great example. Let's say
that's a great example actually. Because
okay.
Yeah, there are cannon rushing bots, so don't worry about that.
Yeah.
This is the best example because almost none of the bots were prepared to a cannon rush, and Crazio, well-established bot author, just entered the cannon rush bot and beat half of the other bots with it.
Yeah, everyone thought he was going to play Terran, then all of a sudden a cannon rush bot shows up. No, but actually, I think Cunibot, I think that's the name of the guy, he made some kind of model. I'm not sure what it was, but it was some cool thing. He took my combat simulator and just started throwing in every single unit and seeing how it would change the tide of the battles. And just like, okay, I'm just gonna throw in more units until I like have the perfect army composition according to the simulator.
Basically, adaptability is one of the challenges. Like, there is no set answer on how to solve that. That's part of the challenge.
Yeah, absolutely. Adaptability is the hardest part of bots, and it's what makes bots a lot harder than playing the games, than playing games yourself.
So with that in mind then, I know that, for example, a lot of human build orders, or like the standard meta for a lot of Brood War games, revolve around this idea that I wouldn't quite call it the same level of adaptability as like, oh, I was planning to do this build order and a cannon rush showed up. But maybe you're relying on specific time, or like scouting certain things from your opponent that aren't just always going to be happening at 5 minutes or like 7.5 minutes into the game. It'll be, I saw the first like mutalisk or something, so now I need to start my missile turrets, but maybe I don't have an engineering bay yet. Like, are there any kind of helpful, I guess, pieces of advice that you guys could give for people who are trying to figure out how do you like start moving to the next step of your quote unquote build order or your plan with your bot that you've already programmed it out? It's not necessarily that you're changing your game plan, but how to react and know how to move to the next steps of each one of your game plan, build orders, or composition.
Well, yet again, that is something that AI is about. We are constantly searching for an answer to that.
Yeah, there's no standardized way to do it. People use their own heuristics, and like they say, like, by this time, if I've seen them take an expansion, like this many expansions, I'm gonna expect Mutalisk to come at this time point. Basically, it's just heuristics all over the place, and you're gonna have to use some kind of machine learning model or your own heuristics for yourself until you like get the result you want.
I see. So something like on frame, 3,700,000,000 or something, go check and see if they have an expansion. And if they don't, then you say like, oh, okay, now this is like in some sort of data structure that you're maintaining for like that represents your game plan. You're going to say like, now is the time to go do this.
Yeah, pretty much. It's probably hard coded if it's not machine learning. So you probably just have code like if they have this many expansions or this many bases, just expect to start building the engineering bay at this frame number.
There are quite a lot of triggers that happen this way. For example, if I'm Terran and seeing some air units, then I should start building Goliaths. You can see this with Seda, who instantly switches to Goliaths when sees an air unit. So yes, this kind of stuff can be coded easily, but on the other hand, these kind of stuff always have side effects, and there are many games lost by over adapting to some strategy, like making 10 million scourges and the enemy literally had just one air unit. So this can happen.
Yeah, and this is when like using a combat simulator for deciding what kind of units you want to use is probably a better choice than just saying, if I see an air unit, make infinite Goliaths. Just like have some kind of reasonability behind it.
But to answer your questions, what kind of advice for improving? Well, that's the gist of it, right? What kind of advice would we give for improving your bot? Well, I would say, and that's just my personal opinion, focus on one thing at a time. Don't try to do everything at once. You don't need to beat everyone. You just need to beat consistently more and more people. So, for example, work on your GUM micro, work on your building placement, work on your pet finding, and do not get discouraged by your win rate. That's mostly not is what is this about, especially because the top bots are either professional researchers or professional teams. You're not gonna beat them on day one. Later, it's absolutely possible. Again, Locutus, who is a lone wolf and just develops the bot in his spare time, and
Crazio.
Or Crazio, yes. But
Microwave.
And Microwave, yeah.
I would argue
lots
that
of others.
Yes, but I would argue that Crazio is doing this for a long time and not in the same league as a beginner.
Fair.
And lastly, don't be afraid to ask for advice. I find that this community is very helpful towards beginners and towards each other, except if you dare to insult the Dengant, then we will set fire to your house. But about programming questions,
I thought his name was Dan Grant.
Oh, it definitely is.
Yes. So the first step of developing bots is accepting Dangent as your Lord and Savior. That's not a step that you can skip.
Can you give me context for what this meme is?
Yeah. So Dangent is a famous AI researcher who wrote Purple Wave, the winner of this year's SSEIT tournament, and also a member of the Facebook's Cherry Pie team. And he's very, very helpful and encouraging towards everyone, but especially beginners. So we joke with him all the time.
It's just a joke. He's just a helpful guy on the Discord.
Oh, that's awesome, though. I love that. One thing I forgot to ask also was, I know you guys mentioned there's the Discord. How can people find the link to this Discord?
I will provide an invite link for this podcast, but also in the SSCIT page and the Twitch page you can find it, I think.
And on the BWAPI GitHub page, I think.
Hannah's too fast.
Okay, any more questions?
No, I think you guys did an awesome job of explaining most of the stuff without getting into like the super nitty-gritty details of, line by line what stuff looks like. I think you guys provide a lot of really good resources, and I feel much more ready if I want to dive into the Brood War AI stuff.
It's a fun journey.
Yeah, it really is. I'm glad we could help.
Yeah, likewise. I think this is a great point to conclude our cast for today. So
thank you so much.
Thanks everyone for being here. And if you would like and got some experience in Brood War AI development, we can continue this and have another cast when you're more experienced and wizened and scarred by overjoyed with bot development. We can repeat this. So thanks and goodbye.
Thanks for
having
having
me.
Thanks.